In this video, I'm going to walk through the answer key for Friday's quiz. Please make sure that you do copy down the work that I show in this video. I want it to be absolutely clear what I expected to see for results in this quiz. So in problems number 1 and 2, I think most people did this pretty well. We're looking to find the solution for x in number 1, and so to do that we take the square root of both sides of the equation. Now I would prefer to see that you actually write the square root sign here. This would then allow us to find the results for x. And we know that when we introduce the square root symbol, then our answer is actually separated into two parts, both a positive and negative 10. For number 2, when we take the square root of both sides of the equation, it does isolate n on the left, but we're left with both a positive and negative 1 as a solution on the right. So these are two good solutions for number 1 and 2. Number 3 and 4 introduce just an extra step to this process. And what we have to do here is divide by the coefficient that's out front. We can't get at this b by itself until we eliminate the coefficient that's here. And so in this case we can divide both sides by negative 3. This leaves us with b squared equal to a positive 25. And now we can introduce the square root symbol and see that b is equal to a positive and negative 5. Over here we've got a negative sign in front of p squared. This is just like saying we have negative 1 here. So if I divide both sides by negative 1, this leaves us with p squared equal to a positive 49. And when we introduce our square root symbol, this will leave us with p equal to a positive and negative 7. Now when we solve number 5 and number 6, the work is still very similar. We're trying to isolate the variables, and in order to do that we should move this constant value first. I'll move it to the other side of the equation by subtracting 7 from both sides. This leaves us with n squared equals 16. Now when we square root both sides of the equation, we're left with n equal to a positive and negative 4. On the right side, we can add 10 to both sides of the equation. This leaves us with x squared equals 16. Therefore, x is equal to a positive and negative 4 after we introduce our square root symbols. For number 7 and 8, we were asked to find the value that completes the square and then rewrite as a perfect square. So the rule to find this is we look at this value here that's in the middle of the group and divide it by 2. Now 38 divided by 2 is equal to 19. Once we have this cut in half, we then have to square 19, square the number that was half of this. So 19 squared is equal to 361. So the value needed to complete the square is this 361. And when we rewrite as a perfect square, it looks like this: x minus 19 squared. So I was looking for both parts here, since the instructions asked for both. Now this process is really important when we actually solve the quadratic equation by completing the square. We have to show both of these steps, and you'll see that again in just a moment. For number 8, half of negative 8 is negative 4. Negative 4 squared is 16, so 16 is the number that we use to complete the square. And to rewrite this as a perfect square, we would write this as x minus 4 squared. So again, both parts were needed for these two answers. Number 9 and 10, we solve the equation by completing the square. So the first thing that we need to do is give ourselves some room to complete this square. And the number needed to complete this square is half of 2 squared is 1. Half of 2 is 1, and 1 squared is 1. You have to keep in mind that we do add 1 to both sides of the equation to keep that equation balanced. And now we have a plus 1 squared equal to the number 9. Now this step over here on the left-hand side of the equation is very much similar to the work that we did in the last 2 problems. We completed the square and we wrote it as a perfect square. So that process is repeated when we solve using the completing the square method. And we're not quite finished here. We've got just a little bit further to go. I just wanted to point out how similar these 2 steps are to what we did just a moment ago. We're trying to get at this variable a, so that means that we should square root both sides of the equation, because to get at this a value, we're going to kind of work backwards through the order of operations. We've got to eliminate this exponent before we can eliminate this positive 1. Now when we do square root both sides of the equation, what we're left with on the left side is a plus 1. These 2 parts essentially cancel each other out. And we're left with just the a plus 1. And on the right, we're left with a positive and negative 3, because the square root of 9 is both positive and negative 3. At this point, since I have an expression equal to 2 different numbers, I recommend rewriting this as 2 separate problems. Either a plus 1 is equal to 3 or a plus 1 is equal to negative 3. So at this point, we can subtract 1 from both sides. We see that a is equal to 2, or when I subtract 1 over here, a is equal to negative 4. Let me show you this next example silently. I hope this video helps you understand the correct solutions to Friday's quiz. Stay tuned for another video so that you can see some applications of quadratics in the real-world scenarios. We'll need to know them as we move forward and finish this unit.